Hello everyone. In this video we will talk about different combinations of capacitors and solve some of the relevant questions. So as you can see in the first combination, these three capacitors are in series. The second one is parallel. The third one, C1 and C2, are parallel with each other, and C3 is in series with them. And the fourth one, we can see C1 and C2 are series, and then C3 is in parallel with them. So moving to the question, for each of four circuits shown in the figure, calculate total capacitance in microfarad if each capacitor has a capacitance of 100 microfarad. So for the first one, all three capacitors are in series with a capacitance of 100 microfarad. 1 upon 𝐶eq is equal to 1 upon 100 plus 1 upon 100 plus 1 upon 100. So as the denominator is same, we will add the numerators and put in the same denominator. So we will get 3 upon 100, and then we will flip the other side. As it is 1 upon 𝐶eq, we will write 𝐶eq and then flip the other side to 100 upon 3, and the answer we get is 33 microfarads. In the next part, all three capacitors are in parallel with each other. You have to remember that when the capacitors are in parallel, we just add them all simply. And if they're in series, we add the reciprocals. So 100 plus 100 plus 100, we will get 300 microfarad total capacitance. So here two capacitors are in series and the third one is in parallel with them, and each one is 100 microfarads. Now these two capacitors are in series, so we will take reciprocal of these two, 1 over 100 plus 1 over 100. This will become 1 plus 1 over 100 or 2 over 100, and then again we will flip the equation like we did in the first question. So 100 upon 2, we get 50 microfarads. So now the diagram will become something like this, as we have found the equivalent of the first two capacitors and we have to add the third one to it. This is 100 and that one is 50. Now we will add C equivalent. It will be 50 plus 100, as the capacitors are in parallel. So we will get 150 microfarads. So in the fourth part, two capacitors are in parallel and the third one is in series. So first we will find the parallel ones. 100 plus 100 is equal to 200 microfarads. Now the diagram changes to this, and we will again have to add the reciprocal of both of these as they are in series. So this is 100, this is 100, both of them combined is 200, and the remaining one is also 100 microfarads. We will add the reciprocal of these two. 1 by C equivalent, it will be 1 by 200 plus 1 by 100. So we take 200 LCM, and 1 plus 2, it will be 3 upon 200. And 1 upon C equivalent. 1 by 200 plus 1, so C equivalent equals to 200 by 3, which is almost 70 microfarad. So let's move on to question number 20. It says three capacitors, each of 120 microfarad, are connected together in series. This network then connected to 10 kilowatt supply. Calculate A, their combined capacitance in microfarad, B, the charge stored, C, the energy stored. So here we have three capacitors connected in series with a 10 kilowatt supply. We have to find equivalent capacitance, the stored charge Q, and the energy E. As these capacitors are in series, so their reciprocal will be added to find the equivalent capacitance. So 1 upon 𝐶eq is equal to 1 upon 120 plus 1 upon 120 plus 1 upon 120. So we take 120 as the common denominator and we add ones on top. We get 3 upon 120. So we flip both sides. We get 120 upon 3, which is equal to 40 microfarads. So for the Charge stored, we have a very simple formula, C equivalent into V. C equivalent we just found out, and V is 10 kilovolts, which has been given to us. So we just multiply 40 microfarads and 10 kilovolts. So we multiply 40 by 10, we get 400, and then we add the powers of 10, we get -3, 10 power -3. So we divide 400 by 1000 and we get 0.4 coulombs. So the formula for energy is given by 1/2 C equivalent into V square. C equivalent we found is 40 microfarads, and then V is given by the voltage that has been given to us, which is 10 kilovolts. So we solve this, we divide 40 by 2, we get 20. 20 into 10 power minus 6 into 100 into 10 power 6. So we cancel both of these, and we are left with 2000 joules. Moving on to question number 21. A 20 microfarad capacitor is charged up to 200 volts and then disconnected from the supply. Then it is connected across a 5 microfarad capacitor. Calculate A, the combined capacitance of the two capacitors, B, the charge they store, C, the potential difference across the combination, D, the energy dissipated when they are connected together. So here we have a 20 microfarad capacitor connected to a 200 volt supply, and then with the help of a switch we will disconnect it later and connect it to a 5 microfarad capacitor. So here we have to find equivalent capacitance, stored charge, potential difference, and energy. For equivalent capacitance we will simply add both of them, 20 plus 5 microfarads, so we will get 25 microfarads. That is our equivalent capacitance. For charge we use Q is equal to CV, and now C will only be used by this 20 microfarad capacitor because it is the only one capacitor connected to the battery. So Q equals to 20 into 10 power minus 6 into 200. So it will be 4000 divided by 1 and 6 zeros. We cancel these zeros, and then we were left with 4 into 10 power minus 3. So this gives us 4 millicoulombs. For V, we will rearrange Q is equal to CV. So for V equals to Q by C, we will put in the values of Q and C respectively. So 4 into 10 power minus 3 upon 25 into 10 power minus 6. You can simplify this using a calculator. So for energy, we use 1/2 CV square. Here we will only use the 20 microfarad capacitor as it is the only one getting the energy supply. For V, we will use 200. Here we divide 20 by 2, we get 10. 10 into 10 power minus 6 into 4 into 10 power 4. We can simplify this by using a calculator.